Hey everyone, this is my very first YouTube video on my math YouTube channel. I'll basically be creating math videos that are engaging for you and are easy to understand. At least I hope they're easy to understand. Revolving around grade 10 math content. I can do grade 9 and 11 content. Grade 10 I just found was in the middle and it was just easier for me to help tutor people on. And that's basically it. So starting off, the very first math video that I would like to go over, like the very first math topic that I would like to go over is factoring, because factoring you'll probably use throughout grade 10, and if you take math later on, grade 11 and 12 also. So what is factoring? Factoring is when you break down numbers in an equation that when multiplied together again give you the original equation. So essentially, what is that something, right? We'll call it something for now because it's called a factor, but we'll go over that. What is something that you can take out of the equation that is divisible by all terms, that if you were to distribute it back in, you were to get the original equation. So something that you can take out of the equation that is divisible by all terms, if you were to distribute it back in, gives you the exact same thing. And that's something you take out is called a factor, right? The factor definition here is a number that you multiply with another number to get a product, right? And that's basically what factoring is. And throughout grade 10 and your math journey in high school, there's going to be a lot of factoring techniques that you learn. And the major ones that you do in grade 10 is probably factoring by using greatest common factor, common binomial factoring, perfect square trinomial factoring, difference of squares, and the grouping method. So getting right into it, starting off with greatest common factoring. And again, just like its name, we learned what a factor is, something that you take out of the equation that is divisible by all terms, and if you were to distribute it back in, gives you that exact same value, gives you the exact same equation. So this one is a greatest common factoring question. And some people may ask, how do you know if it's greatest common factoring? How do you know it's common binomial? How do you know it's grouping method? Again, it just depends on the questions. Once you start seeing the questions over and over again, you will understand and you will see what methods to use, right? You have to make that judgment, but after practice, you will get it. So this one is a greatest common factoring question. And how I know is it doesn't fit any of the criteria of anything else, and I'll explain that later. With greatest common factoring, you can have as many terms as you want. In this case, there are two terms, 2x cubed and 6x squared y. Those are the two terms, but you can have 5, 6, 7 terms, 5 terms, right? It just varies. And again, greatest common factor. So we look at something that is divisible by everything and we just take it out of the equation. So everything here, we look at the coefficients first. The coefficients are 2 and 6. What is divisible by 2 and 6? And it has to be the same number. What is divisible by 2 and 6? 2, right? 2 divided by 2 is 1. 6 divided by 2 is 3. So we already know, we already know that 2 is the start of the factor, the start of what we are going to take out. Now we move on to variables, because you can have variables in an equation and you can take them out. You always want to look at what is the same variables and what are different variables, right? What variables are the same between both terms. Each term has x, but only one term has y. So therefore we can't take out y, because if we distribute it back in, 2x cubed, right, does not have a y value. So it wouldn't make sense. They both have x, and what you always want to do is you want to take the variable with the lowest exponent value, for example. And that exponent value can also be 1, right? Because if we just see x by itself, we also assume that it's to the power of 1. So we just pick out the lowest, we pick out the variable with the lowest exponent to factor out. Even though some people might get confused, greatest common factor, you think, oh, greatest exponent. No, you have to take out the the variable with the lowest exponent, because even if we do the math and distribute it back out, just so I can show you guys, you'll see why we take the one with the lowest exponent. So it'll be 2x squared. So that means this 2x squared is a factor of both terms here. And if we try that out, the factor again has to be divisible by both terms, right? And when you divide it by the term, it will give you an output value. And that output value is what you're going to put in brackets, right? Because that's what you're going to be left with. You can't get rid of it, right? Because it's not fully divisible, but that's what you're going to be left with. So 2x cubed over 2x squared equals, if we do that, 2 and 2 cancel out to give you 1. 1 times anything is just itself, so we don't have to write 1. And then using exponent laws, 3 minus 2, because when there's division, you have to subtract exponents, gives you x to the power of 1, or just x. So that means what's left over after dividing 2x cubed by 2x squared is x, right? And then we have to carry the multiplication, the subtraction sign down, and we're going to get, just the minus. And then we do the same thing with the second term. Again, you can do this mentally, but for your guys' sake, it's easy for me to write out to show you. 6x squared y divided by 2x squared. Now, what is 6 divided by 2? 6 divided by 2, 3. Again, we look at the variables now, x squared over x squared. That's like saying x to the power of 2 minus 2, because you have to subtract the exponents. 2 minus 2 is 0. Anything to the power of 0 is 1. So we don't have to write the 1 because, again, 1, anything times by 1 is just itself. And then we're left with y. So it'll just be 3y. So the final equation, or your final simplified form, will be 3y. And that's it. That's its simplest form to be simplified in. Some questions on a test or on quizzes, they just might put like a question like this or a longer one and say simplify or factor. And this is what you would do. You would factor it fully. And that's it. So again, when you factor something out, if you were to distribute it or FOIL it back in, you would get the original equation that you're given to factor. So if we do that right now, we distribute it, because distributive property, we're going to get 2x cubed minus 6x squared y. And that is our original value. So this is the final factored form. Moving on to the other method is factor by grouping. Factor by grouping also has some greatest common factoring, type of method in it, but we'll show you. So by factoring by grouping, what you have to do is group the first two terms in a bracket. And then just like that, you group the first two terms and the last two terms, and then you look just like in the first question, what is common between this bracket and what is common between this bracket. Now we start with the coefficients and move on to variables. 3 is common because 6 divided by 3 is 3. 3 divided by 3 is 3. Now we move on to variables. What is common? One term has n, and then the other term does not have n. So we can't factor out n, but we can factor out m. So this and this. And the lowest exponent of m is m to the power of 1. So then we just factor out m, like that. And then what we're left with in the brackets is 2m plus n. Because if we distribute 3 back in, it will give us our original bracket that we group together. And that's it. Same thing with the last bracket. You can also factor out negatives too, right? And it's not that bad. You just have to change the sign in the middle. But when you factor out, you look at the coefficient, -4, and then this one is -2. You pick the lowest number, lowest exponent and lowest number that you can factor out. So you can factor out -2. Can you factor out any variables? No, because none are common. So you're going to be left with 2m. Sorry for the interruption. So yeah, continuing on. Where were we? Okay, yeah. So -2, we factor out -2. So then we're gonna be left with 2m in the beginning of the bracket, and -2n divided by -2 is just plus n, right? And then that's what you're left with. You're not done yet, right? Because you still have to factor it further. You can factor it further. Now, this also involves another technique called factoring with common binomials. And factoring with common binomials is fairly simple. You basically look at what are common binomials, and binomials are things that have two terms in it, right? And the two terms are 2m plus n, 2m plus n. Those are the common binomials. And just like anything else, if we were to factor them out, what would that leave us with? So factoring out binomials is so very easy, and I'll show you one method that helped me start off to know how to factor common binomials. We're gonna let 2m plus n equal y. Okay, just for now, let 2m plus n equal y. So then that's going to be left with 3my minus 2y. So now we're given two numbers, right? And we look at the numbers and we see what is common between the numbers here. Y is common, m is not common, and the coefficients aren't divisible by anything. So this can be written as y 3m minus 2. But obviously we can't let that y stay like that because we let y equal something. So what did we let y equal? 2m plus n. So then it's going to be 2m plus n bracket what was it? 3m minus 2. And that's your final answer. 2m plus n, 3m minus 2. That is this equation right here simplified. Another way, instead of, if you don't want to let it equal y, because you don't have to let it equal y, you want to save time too also, right? You can just look at it with your eye. It takes practice, but you just look at it, right? 2m plus n is the same. One term has 2m plus n, the second term has 2m plus n. So what you can just do is you can actually just, give me a second, let me change the color. What you can do is you take this term and this term, and you can rewrite it as one bracket as 3m minus 2, because you already know that 2m plus n and 2m plus n are common with both of them. So if you wanted to factor out 2m plus n, it would be 3m minus 2 and then 2m plus n. You can just automatically go to that, and that's your simplified form. And again, it does not matter which bracket is first, the 2m plus n or the 3m minus 2, because when you're multiplying it out, you're still going to get the same answer. And that's grouping by factoring. That's the grouping method. Now, moving on to perfect square trinomial. This one is also fairly easy. What you basically want to do is look at the first term and then look at the last term. See, are they perfect squares, right? And this only works for things that are trinomials. Trinomials are things that have three terms, right? 1, 2, 3. And you look at, do they have a perfect square root? So what is the square root of 49b squared? That is going to be 7b. And then same with 16, because you have to look at the first and the last term. What is the square root of 16? 4, right? And you're just given that. Now, what you can do is, usually the general format of a perfect square trinomial stays the same. It's always the first value, the square root of the first value minus the square root of the second value squared. So, for example, m minus n squared. That's like your general formula. And remember, m would be the root of 49b squared, and n would be the root of 16, right? And then basically that would just be 7b minus 4 squared. And then if you were to distribute this out, you would get your original equation given to factor this value. And that's it. This is very simple, this one. Obviously, you have to determine whether it's a perfect square trinomial looking at the first and the last term. And that's pretty much it. That's the other method. And moving on. And then now we're going to move on to the other method, which is difference of squares. And difference of squares follows a formula. And the formula is fairly simple: a minus b bracket a plus b. And essentially, in this case, a is your first term, b is your second term. So a and difference of squares, so it has to do something with squaring. So in this case, it's the perfect square root of the first term and the second term. So a would equal the square root of 16e squared, and b would equal the square root of 125d squared, right? So simplifying them, you're going to get 4e and 5d, right? And then you just follow the general format. What does a equal? A equals 4e, so you're going to get 4e minus 5d, and then the same thing in the second bracket, 4e plus 5d. And that's pretty much it. Again, you have to look at the perfect root of the first and the second term, and that will determine if it's a different square trinomial. If they are not perfect squares, right, then it's probably a greatest common factoring question, and then you just factor out the greatest common factor, and that's it. And that's it. The last one, which we already discussed, is factoring out a common binomial. And to start off, I was very confused by these, because like, how can you just factor out a binomial with two terms inside of it, right? Because you think, wow, two terms, like it was just very weird to me, right? But what you have to consider is that looking at these brackets, right? Looking at these brackets, that's like one, you have to represent it as like one thing, right? So the 3x plus 1 in our bracket is one thing. It's like it's just one kind of term. Yes, that's a great way to put it. That's one term, right? And so what I did earlier, by letting it equal something, it really helped me. And then I just didn't use the let the binomial equal y ever again, because it was just I got used to it, and it just made more sense to me, right? So again, it takes a lot of practice, but it does work out. So just for the beginner's sake, I'll do let y equal 3x plus 1, right? And that square right here might throw some people off, but don't worry, guys. We'll go through it. So let y equal 3x plus 1. Now, we know there's a 3x plus 1 in the first term. Second term, there's another 3x plus 1. The thing with the first term is that it's squared. So that's like, again, you follow the same rules, same logic, y squared, because there's this repeating two times. Just y squared minus 5y. And that's it. Now again, you look at what's common between both terms. Y squared does not have a coefficient, so we can't factor out anything there. Although y is common between both terms, so we can factor out y. So it's going to be y bracket y minus 5. And then that's pretty much it. So all you have to do now is just do this, and then again you have to substitute what you let y equal back in. So it's going to be 3x plus 1 bracket. And we're going to do big brackets here because I'll show you right now why. 3x plus 1 minus 5. So, looking at this, what you can do now is actually simplify this. And to simplify this, it's not that hard. What you're firstly gonna do is, again, rewrite what's at the top, but then you're still gonna remain with like the big brackets or whatever, and then take everything out of this small bracket that I just highlighted. So what you're going to do is get rid of the small bracket. So then it's just going to be 3x plus 1 minus 5. So then all you have to do now is just collect the like terms, use BEDMAS or whatever, and simplify. So the only two terms here that are the same are 1 and negative 5, because nothing else has a variable other than 3x, so that can be simplified. So then we just have 1 and negative 5. So then 1 minus 5 is just negative 4. Therefore, this will be your final answer. And that's practically it for factoring. I mean, those are majority of the techniques that you'll probably use in grade 10 math. If you want me to go in greater depth of any of these techniques, feel free to comment or ask. If you have any advice for me, please let me know in the comments. If you enjoyed this video, please leave a like and subscribe. Have any feedback, again, please leave a comment. And that's basically it. Thank you all for watching, and I hope you have an amazing rest of your day, night, evening, or whatever. See you guys.